Hello my dear EAPCET aspirants. I welcome you to NEET World. So in this session we will be discussing EAPCET 2025 question paper. Okay, so in this session we will be covering chemistry part of EAPCET 2025 examination which is conducted by Telangana State. Okay, TS EAPCET paper we will be discussing here. The first question here, it is mentioned that the energy associated with the electron in the first orbit of hydrogen atom is this much. Okay, the frequency of light required to excite the electron to fifth orbit. Okay, so how can we solve this kind of questions? Okay, so what is the formula we have? So for energy and frequency, so see here, so we have a simple formula between these two things. So energy equals to, so what is the formula we have? H nu we can write now. So using this also we can solve this question. So what is the energy they mentioned? Minus 2.18 into 10 power minus 18 joules. Okay, so H I can say 6.626 into 10 power minus 34 joules second into this one, frequency. I am writing as it is. So we need to find this frequency. Yes, simple. By simplifying this, see, joule cancel, and this one will also get cancelled, and here we will be having 10 power minus, if it is 24 means 16, minus 16 we have. Okay, so finally frequency how much we got here? So here we have the frequency as, see, this is the energy, just take the magnitude, not required this sign also. So just take 2.18 by 6.626. Okay, so in the denominator 10 power minus 16 I have, I am writing in the numerator as 10 power plus 16. Can write like this now. Okay, I hope it is clear, and this will become second, if it is coming into the denominator I can write it as second inverse. Okay, so that is nothing but hertz. Okay, from this, so how much we can expect this is, so instead of writing 2.1 I am writing it as, so I am writing it as 21.8 into 10 power 15. Okay, by 6.626. Yes, we can write like this now. So by simplifying this, so you will be getting around 3 times now. So here we have 3.17 into 10 power 15 hertz or second inverse. So this is our final answer. Very simple now. So this is how you can easily you can solve based on the options and based on the data they have given. So option 4 is correct for this particular question. Okay, so I will be showing that. So what is our final answer here we got? So 3.17 into 10 power 15 second inverse, or we can say hertz. Okay, this is the frequency which is answer for this particular question, which is option number 4 in the given data. Okay, so I hope you got how we have solved this using very simple basic formula from Planck's quantum theory, right? Okay, so now let's have one more question here. Strontium. So strontium atomic number also given 38. The number of electrons with L equals to 0 is X. The number of electrons with L equals to is Y. Okay, so what is the X minus Y value? They are asking about that. So what is the strontium atomic number is 38. So it means how many electrons, like how many electrons are there? We know 38 atomic number means 38 electrons will be present, right? So out of that, the angular momentum L equals to 0. For which orbital L equals to 0? We know for S subshell, L value is 0. For D subshell, L value is 1. L value is 2 for D, and for P it is 1. For F it is 3. Like that we know, right? So from that, so L equals to 0 for S, it means how many S electrons are there, S orbital electrons are there. So those are considered as total number of electrons in S orbital is considered as X number, and total number of electrons in D orbital is considered as Y number. Okay, so what is the value of X and Y? After finding this, we need to get the value of X minus Y is how much? This is what the question asked here. Okay, so I hope, just give me some time. So I just want to adjust the screen first. Okay, somehow it is better. Okay. Okay, now tell me. So how can we write? If we write electronic configuration, what we'll be doing? 1s2, 2s2, like this we'll writing now. So generally consider from it is 38 means it will be having s orbitals, 1s orbital, 2s orbital and 3s orbital as well as 4s orbital as well as 5s orbital. So all of them are fully filled now because this is second group element. So 5 like s orbital will be having 2 electrons. So 5 s orbitals, therefore 5 2s are 10. So x value is 10, and what about y value here? So how many d orbitals are there? Only 3d orbitals we will be seeing now. After 5s we can expect for 4d. Okay, but here 4d will not be involving, 4d 0 but 3d 10. So 3d 10. So 3d 10 means 3d 10 electrons means 3d 10 electrons means, so y value is 10. So x minus y is how much now? 10 minus 10. So this will be 0. So we have option 1 as 0. Hope it is clear how we are solving this kind of question. Very basic question, right? See, the level of paper, whatever the shift may be, whether it is maybe for BPC students or for MPC students, EAPCET questions are almost of similar standards. Okay, so I suggest you to solve whether it is BPC EAPCET paper or MPC EAPCET paper. So you can go through physics and chemistry, which are similar subjects, I mean same subjects or same syllabus for both the streams, right? So you can cover your syllabus from physics and chemistry from even from BPC papers also if you are MPC student, and you can cover from these MPC papers if you are from BPC students. Okay, so that's how you can make your preparation more effective by utilizing more number of resources from our playlist. Okay, the next, they have given list 1 and list 2. Based on that we need to match them. Okay, so electron gain enthalpy is given for these elements. So tell me which element is having more electron gain enthalpy. So which is having more tendency to gain the electron? Yes, so halogens are having more electron gain enthalpy generally. In a particular period if we compare, the halogens are having more electron gain enthalpy than the other elements, and in that also highest electron gain enthalpy value is for chlorine in the periodic table. In the whole periodic table, chlorine will be having most negative electron gain enthalpy here. See, the most negative value chlorine is 349. So I can say C2. So C2 there in which option? C2 here. So 2 options are there, remaining 2 you can eliminate. And the next one we have sulfur. So if we compare fluorine and here we have sulfur and oxygen. See, out of this, oxygen will be having least electron gain enthalpy. So which is having least electron gain enthalpy I am saying. Okay, they have given 5 values. So out of that least electron, it is having negative but least. Negative but least means it is 3. So, okay, so A3. So A3 and C2 I told you. Okay, then next, after chlorine, the most after that chlorine we have fluorine, which is having more negative electron gain enthalpy. So after chlorine I can go with fluorine. So fluorine, the next most value is this much only, more negative. So 328 for fluorine. Okay, so B4. So B4, A3, B4, C2, and next is sulfur we have D1. Okay, so you can remember this orders. That's it. Okay, so for halogens, what are the halogens we have? Fluorine, chlorine, bromine, iodine, right? So in this, which is having most value, it means, so this is for chlorine. Okay, when we compare from fluorine and chlorine, chlorine will be having more electron gain enthalpy, which releases more amount of energy I can say, and this one. So this is what the order you can remember, or the generalized or the summarized order will be chlorine, next fluorine, then next bromine, then next iodine. So this is the order for halogens. Okay, so you can remember. When it comes to oxygen and sulfur, remember sulfur is having more electron gain enthalpy within this oxygen. So in the oxygen family, oxygen will be having least electron gain enthalpy, you can remember that. Okay, so these are the 2 important orders you have to must remember for about electron gain enthalpy. If you want to know more about electron like this properties, periodic properties, so I have covered complete discussion of electron gain enthalpy, ionization energy, electronegativity and the trends very clearly in the playlist. So just go through the NEET World playlist, chemistry playlist for EAPCET or JEE Mains or NEET. So there you will be seeing all this discussion. So without any worries, you can learn from that source. Okay. So I hope it is clear. Our option 3 is correct for this particular question. Next question here we have, electron first ionization, like ionization energy values are given first and second, and the next electron gain enthalpy is given in this third column. So now tell me which element will be more reactive as from the data. Okay, observe the data and tell me using the data identify most reactive metal. Okay, so which is more reactive? Now see, if it is having low ionization energy, it means it is easily giving its electron. If it is easily giving its electron, means it is easily participating chemical reactions, right? So it means which is more reactive? The one which is having low ionization energy. So which is having low ionization energy out of these? The first low ionization energy is for this second element. Okay, so from element 2. So that will be more reactive. So which is more reactive? The one which is having low ionization energy, that is second element. So you can go with this first option which is having second element, right? So based on that you can answer very easily. Okay, so one which is having highest like ionization energy, that is very reactive because it is more, that is very stable, and which is least reactive. What I am saying, more ionization energy means that is more stable, less reactive. Okay, less ionization energy means more reactive. Okay, hope it is clear. Less ionization energy, more reactive. Okay, so based on the values even you can arrange their reactivity order also, right? Most ionization energy, less reactive, you can say. Okay, so now find the sum of orders of O2 plus, O2 minus, O2 and O2 2 plus. So is equals to what? So how much value it is having? So how can we solve this kind of questions? So for O2 plus, how many electrons are there? O2 plus we have 15 electrons total. For O2 minus 17 electrons we have. For O2 16 electrons, for O2 2 plus 14 electrons we have, right? So for 14 electrons bond order is 3, for 16 electrons bond order is 2, for 17 electrons it is 1.5, so for 15 electrons it is how much? 16 means, okay. So here you need to get this. So this is 2.5. So if you observe this properly, so what I have given, 14 electrons I have kept the value as 3. So for 15 I decreased by half, so it is writing as 2.5. So for 16 I have written 2.0. So what is the trend you are observing here? 1.5. See, by decreasing the number of, by increasing the, as number of electrons increases from 14, so their bond order also getting decreased. If number of electrons increases, bond order decreased by half, right? So this is what the trick you can remember, okay, for MOT. Okay, now MOT I have discussed, I have explained very clearly. You cannot even skip, or even you cannot even miss a single question in the exam. From I can say that you can like definitely you can able to score whatever the question they might be asking in EAPCET or any other exam from MOT. You can easily answer after watching that video. So just go and watch it so that you can get more confident on this MOT, molecular orbital theory. Okay, using tricks I have explained. Okay, now tell me. So for 3 plus 2.5 plus 1.5, how much it is? So it is 5.5, 7.5, 8, okay, 8 plus 1, 9. So what is the total value? So 9. So we have here 9 as the answer. So option 4 is the perfect for this particular question. Hope it is clear now how we are doing. Very simple one. Hybridization is not same in both SF4 and SF6 and SFBr-F5. So is it true statement or not? So this is also from chemical bonding, and I have clearly explained. I have made a specified dedicated video on valence shell electron pair repulsion theory, where we will be discussing about the hybridization, shape, structure of these molecules, right? So you can go and watch that also after completing the session. So why I am highlighting them? Because those are the topics where you can definitely expect at least one question. So we should not skip those questions where we can have a guaranteed one, right? Those concepts where we have a guaranteed question, should not skip those. So that's why I am highlighting those videos in the discussion. Okay, so once after completing this you can watch that without any negligence. Okay, so SF6 we have now. SF6 means what? So sulfur is 16th group elements, valence electron 6, and number of monovalent atoms are 6 by 2, 12 by 2, 6. So it is sp3d2. okay, sp3d2 with 6 surrounding atoms, 6 hybrid orbitals, 6 surrounding atoms. So therefore we can get octahedral geometry for this. And for BRF5, so bromine halogen, bromine is a halogen, group 17 elements, so valency electrons are 7, surrounding atoms are 5 by 2. Here also 12 by 2, so we will be getting 6. So hybridization is 1 s orbital, 3 p orbitals and 2 d orbitals. So sp3d2 hybridization, this one. But out of these 6 hybrid orbitals, hybridization number, so 5 are bond pair electrons, so 5 are bond pair, 1 is lone pair. It means in octahedral geometry, so one of the position is occupied by what? By the lone pair electron. Therefore the structure becomes square pyramidal, whereas here in this case is become octahedral. So from this, first one I can say both are not, hybridization of is not same in the both SF6 and BRF5. No, it is same in both case. Okay, so statement 1 is incorrect. Statement 6, BRF5 is square pyramidal. Yes, SF6 is octahedral in shape. So statement 2 is correct. 1 is false, 2 is correct. Okay, so I hope it is clear from the explanation, and we can look into the option now. See, statement 1 is false, not correct, and statement 2 is correct. So that is our answer here. Okay, and then next here we have, let me go through this question. If the standard Gibbs free energy delta G naught for the reaction is minus 115 kilojoules, the value of log Kp. So how can we solve these questions here? So delta G naught, what is the formula? Delta G naught, they are given this much, the value of log P. What is the relation between delta G naught and Kp? So we have equilibrium constant and delta G naught as relation, like delta G naught equals to minus RT ln Kp, right? So this I can write minus 2.303 RT log Kp. We can write in this format. Okay, so now what is the delta G naught value they mentioned? Minus 115 kilojoules, right? You can write it, which is equals to minus 2.303, R value also mentioned 8.314 into 10 power minus 3 kilojoules. Okay, and next temperature is how much now? Mentioned it as 298 Kelvin. Okay, so it is 298 Kelvin into log Kp. So this is what you can take. Okay, so this kilojoules, you can simplify this so that you will be getting the final answer as delta log Kp value. See, minus getting cancelled, so log Kp value you will be getting around plus 20.15. So this is your final answer, which is option number 1. Okay, I have already simplified it, so based on that I am giving the direct answer. Okay, hope it is clear how we are using the formula and how we are substituting here, right? So let's move forward. So 20 ml of aqueous solution of HCl is mixed with 300 ml of aqueous solution of NaOH, okay, and is diluted to 1 liter. Okay, so what is the pH of resulting solution we need to find. Okay, so it is simple again. So for 200 ml of solution of HCl, so pH is mentioned as 2. So if pH is 2 means what is the concentration of H plus? So concentration of H plus will be equals to 10 power minus 2. Okay, so similarly this is for HCl, this is acid. Now we have NaOH, which is a base. Here mentioned that, so this is the concentration and volume mentioned as 200 ml. Okay, this is the thing they have taken, and NaOH pH mentioned as 12, therefore POH will be 2. POH will be 2. Why? Because pH plus POH will be equals to 14 now. So from that pH plus POH equals to 14 at 25 degrees Celsius. From this, if I send this pH to this side, 14 minus 12 will be 2. That is what I have written here. So from that concentration of OH minus will be 10 power minus 2. So how we got these two values means, so if I want to write pH, I can write minus log concentration of H plus. Okay, similarly if I want to write POH, as I can write it as minus log concentration of OH minus. From that we can get this value like this, right? Now what is the volume they mentioned? It as 300 ml. Write it as it is. Okay. After this, the resulting pH, resulting solution pH is how much they are asking. So first of all we need to know whether the resultant solution is acidic or basic. Okay. So in order to find that, so what I am making is concentration of a solution, resultant concentration I want to find. See how many number of moles of NaOH we have. See molarity formula what we have, molarity equals to N by V we can write now. Okay. So from this N by V into 1000 we can write. Okay. So from this, for M in the ml we can write like this. Okay. So from this, if I want to find the number of moles, how many number of moles, I can write M into V by 1000, which is equals to N, number of moles we got here. Okay. So from this number of moles, what is the concentration? 10 power minus 2 into what is the volume? 300, okay, by 1000. Okay, you can write it like this. Number of moles how much? Now this 2 got cancelled. So 3 into 10 power minus 3 I am taking. This is what the number of moles of NaOH. Now number of moles of H plus is how much? Number of moles of H plus will become 10 power minus 2 into 200. So that I can by 1000. So that I can write 2 into 10 power minus 3 moles. Okay. So which is bigger value here? So this is bigger now. So means the total overall solution becomes basic. Why it is basic? Because it is 3 moles, 3 into 10 power minus 3 millimoles, it is 2 millimoles. It means 1 millimole of base is more. Therefore first 2 millimoles from here to we're getting neutralized, and extra 1 more mole of this millimole of NaOH remains in the solution. Therefore resultant solution is basic. So for that, if you want to find the concentration of NaOH, take 3 into 10 power minus 3, and the next this one minus 2 into 10 power minus 3. So this, from this what we will be getting? So we will be getting 1. This is the concentration of number of moles of NaOH, right? So this is the concentration of this is the number of moles of NaOH we got here, right? So number of moles we got. So I want to find pH. So concentration of OH minus, this is in the 1 liter solution now. So how much it is? 10 power minus 3. So if it is OH minus concentration is this much means, so POH formula is what is that? Minus log concentration of OH. So minus log concentration of 10 power minus 3 will become 3. So POH is 3. So from this pH will be what? pH equals to 14 minus POH. 14 minus 3, that is 11. So pH is 11. We have option 2. Okay. So like this you can solve. See, this is a very simple one, but I have discussed everything, like how you can able to calculate number of moles. So from that, how can we summarize this? So that is what I have concluded from the very basic. Okay. If you are already known about, if you are already aware of these things, directly you can solve this very simply. Okay. But I just wanted to give some basic things also. That's why I have taken this much long process. Okay. Hope it is clear. Anyways, option 2 is correct. Identify the electron rich hydride from the given 4 options. So how can we do that? So just tell me in the comment box if anyone in the online. So I just wanted to go through this. Yes, tell me, identify the electron rich hydride from the following. So how can we do this question? See, electron rich, so that compound should contain like more unpaired electron, like non-bonding electron. See, in B2H6, so it is, what is the structure we can write? BH3, B2H3, these are electron deficient actually, because they have only 6 electrons in AlH3, and also BH3, if I say single unit, it will be also having 6 electrons. Okay. So I can say more, they are electron deficient. Okay. So when it comes to HCl and H2S, so just write the structure. It will be like this now. So presence of this non-bonding electrons or unpaired, like non-bonding or lone pair electrons, makes it electron rich hydride. Okay. So this is most appropriate answer here. Okay. So what about this? So these are electron precise. See, write the structure. Like this we are writing now. So no non-bonding electrons or unpaired electrons are lone pair electrons present on the carbon, therefore it is electron precise. All electrons are involved in the bond formation, right? So it is electron precise. This is precise, this is deficient, this is rich. Okay, I hope it is clear. So option 3 is correct. Incorrect statement about Kastner-Kellner process. So what is this Kastner-Kellner process? So this process is used for preparation or production of sodium hydroxide, right? NaOH production. Okay, so what we will be using? We will be using brine solution. So we will be using brine solution, the electrolyte, and sodium hydroxide. NaOH is prepared. Yes, both statements are correct. They are asking about incorrect one. So mercury act as anode and carbon act as cathode. No, this is the reverse one. Mercury act as cathode and carbon act as anode actually. So this statement is incorrect. You can choose this one. Okay, so at anode what happens? Cl2 gas is liberated. Okay, at anode what happens? Cl2 gas is liberated. That is at the carbon electrode, Cl2 gas is liberated. Okay, that is what we will be observing, but third option is incorrect. So you can choose third option. Okay, so next one is okay. Next we have by using which process sodium bicarbonate is generally produced. So from this, so just now we discussed Kastner-Kellner process is for what? Production of NaOH. Nelson process is also for production of NaOH. For Deacon's process for preparation of chlorine, right? And soda solvay process is the best option for preparation for sodium carbonate. Okay, soda like soda solvay process we say, or simply solvay process, which is suitable for preparation of this sodium carbonate. Okay, hope option 4 is correct for this. Next, which of the following is incorrect statement? Tell me which is incorrect one. So all trihalides exist except TlI3. So thallium iodide is not exist. Why it won't exist? Because of Tl+3 oxidation state. See, 13th group elements can show two types of oxidation state. So that is +1. Generally these are +1 and +3. Okay, so +3 is a higher oxidation state. Okay, so why it is? Because its general electronic configuration is ns2 np1. By losing one electron, this p orbital electron, it will become +1. By losing all 3 electrons, it becomes +3. Okay, so now down the group what happens is, due to inert pair effect, the +3 oxidation state stability decreases. So thallium will be having only +1 oxidation state compounds. Okay, because +3 oxidation state stability very unstable for this thallium. Therefore it cannot form thallium iodide. Okay, in the +3 oxidation state. Therefore this is unstable and it won't exist. Okay, okay, this statement which what they are asking us. So which are the following is incorrect. So this is correct only. All trihalides exist except TlI3. Okay. Okay. Trihalides on hydrolysis forms tetrahedral species. Okay. Let's see once again. So they are asking about incorrect one. No? This is correct only. This is also correct only. Diboron is an example of electron precise hydride. No. So diboron is what? Diboron is what? BH3, if I say this is a monomer, dimer of this, that is double of it, B2H6. Just take 2 units of this. Okay. So here it is having 6 electrons only, na, which is electron deficient. Okay, that's why it is not existing in this monomeric form, it is existing in dimeric form. Even it is existing in dimeric form, so it is having less electrons, 12 electrons only, right? So we can call it as electron deficient but not the electron precise, right? So option, this is the incorrect one, you can choose it. Okay, so hydrolysis of diboron will be producing boric acid. Yes, so if you hydrolyze this, so we have H3BO3. So in the last paper also, in the other shift also I have seen a question on diboron. Okay, so I know diboron is one of the very important topic. So I have covered a specific video of 10 minutes where I have covered all the preparation properties of this diboron. So that will be definitely a good and very useful content for your preparation. Just go and watch in the Golden Minute series in the playlist of this NEET World channel. So just go and watch it after completing this session. Okay. Next, the incorrect statement about oxidation states of 14th group elements. Yes. So what is the incorrect statement? Plus, in addition to +4 and +2, carbon shows negative oxidation states. Yes. So for example, methane if I consider. So methane if I consider. So in this, carbon is having -4 oxidation state now. So it means the statement 1 is true only. Okay. So it can show even negative oxidation states also. That is correct. Next. Tin in a +2 oxidation state act as reducing agent. Okay. Lead in +2 oxidation state as act as reducing agent. See, what do we mean by this reducing agents? First tell me that. So reducing agent means reduces others and oxidizes themselves. So already tin and lead. So let us take them Sn +2, tin +2, lead +2 and tin, lead +2, tin +2 I have taken. So if they are saying as they are undergoing oxidation, they are acting as reducing agent means they should undergo oxidation and reduces others. See, what do we mean by reducing agent? They will reduces others and oxidize itself or themselves. So it becomes oxidized. It means +4. Here also it becomes +4. So but what we know, +4 oxidation stability down the group decreases, right? Decreases. It means, so this +4, lead +4 is highly unstable due to inert pair effect. So therefore +2 oxidation stability increases. So it is not a good reducing agent, because in +2 only it is already stable. But if it is undergoing, if in order to act as a good reducing agent, it should undergo +4, which is highly unstable. So this process, this option is not at all a proper or correct one, because not a correct option, because it is already stabilized in the +2 only, not in +4. So you can choose option 3, not the other one. Okay. Next. In drinking water, if the maximum prescribed concentration of copper is X, okay, the maximum prescribed concentration of zinc is how much? Okay. So for, see, directly I will be telling you, for copper it is 3 ppm, around 3 ppm. Okay. For zinc it is 5 ppm. Okay. So these are the values you can check for, you can refer the NCERT book, where you have discuss, like there is a table in the, like in the chemistry in everyday life, I think so. So there you will be seeing across, you will coming across these things, okay, in a table like metal contamination and all. Okay. So they have given 15 by X. So X is for copper, Y is for, I mean, what is the maximum for zinc they are asking. If it is 3, 15 by 3 will be 5. So it means 5 will be for zinc now. So it is 5. So first option is perfect answer for this question. Okay. So let's discuss about the other one. Yes, again here we have from organic. Okay. So what is the empirical formula D? Yes. So like this interconversions are very important. Okay. So just give me some time. So just try to solve from your side. I will be looking into the comment box, anyone in the online. Yes. Here we have C2H6, so which is ethene. So let me take that pen. So here I am writing C2H6, C2H4. Okay. So this is alkene ethene. So to this we are adding bromine in presence of CCl4. So Br2 CCl4 we are adding. Okay. So CH2 CH2. So just add bromine, here one bromine and here one bromine, that's it. So this is our A. Okay. So to this we are adding alcoholic KOH. So it means what is a purpose of this, it will be showing elimination reactions. It means one of this bromine will goes from one of the hydrogen from beta position and forms something like this alkene. Okay, after this, here we have followed by NaNH2. This is a strong base, so that will also take one more proton from here and Br minus from here and will forms alkene. Okay, so that is ethine. So what is our B? Ethine. Okay, so these B undergoing polymerization, cyclic polymerization, so which is forming a benzene ring. Cyclic polymerization will results to form benzene ring. So this benzene ring upon treating with Cl2 in dry AlCl3 and dark condition, see here we have on each benzene, each carbon in the benzene, where there is one hydrogen. So just replace this hydrogen, remove H plus and replace with one chlorine. That is what electrophilic substitution reaction takes place and forms benzene with chlorines on all the carbons in the place of hydrogens. Okay, like this. So what is the formula? C6Cl6. This is our answer. So what is the empirical formula? What is the empirical formula for this? CCl. CCl is the empirical formula. So this is a molecular formula. C6H6 is for benzene, C6Cl6 for this compound. Now the simplest ratio what we can write? CCl whole 6 times, right? So in the bracket what we have? CCl, that is our empirical formula. So this is our answer for this question. Okay, do we have any option like that? Yes, CCl, first option, it's second option we have, that is our answer. Okay, I hope it is clear. Yes, again steam distillation, I hope we already solved, we have seen one question like this in the previous papers also. So what is the steam, what is the mixture that can be separated by steam distillation, which is like water plus aniline. What is the IUPAC name for this compound? See, first of all identify what are the functional groups. Okay, so now you have to number this longest carbon chain by giving the minimum number for the substituents and also especially for the functional groups. So if I come from here 1, 2, 3, 4, 5, 6, 7. Okay, so this is getting 1, 2, 3, 4 and 5. Okay, so 2, 4, 5 we are getting. If I come from here, so 1, 2, 3, 3, 4, 5, 6, 6. So it is better to go from alkene carbon, not from alkyne here. So I am giving the numbering as 1, 2, 3, 4, 5, 6, 7. Okay, so now at 2 carbon we have ethyl and here we have methyl. So I can say E comes first now. So 2 ethyl, next hydroxy, not hydroxy because this is a parent principal functional group now. So that name should end with the principal functional group ol. So pentane like 7 carbons na, heptanol, like that. Okay, so 2 ethyl, 5 methyl, hept, 7 carbons hept. Okay, hept, 1 in and 6 ine. So do we have any option like this? See, 2 ethyl, 5 methyl, hept, 1 in, 6 ine. So next what is the position of alcohol? 4 na, so 4 ol, that's it. So this is our option. Option number 2 is correct for this question, right? Let's move further. An alkane has molecular formula C6H10. So how can we write the structure of that? The number of 1 alkynes. So it means the triple bond should present only at the terminal position. Okay, so no need to worry about stereoisomers, that asking only structural isomers and placing the triple bond at the terminal side, terminal of the carbons, okay, of the chain. Okay, 1, 2, 3, 4, 5, 6 carbons. Okay, so to this I can place triple bond here. Okay, this is the one possible structure. 1, 2, 3, 4, 5. Okay, so to this I am placing triple bond here and methyl group here, and similarly, so I am placing triple bond here and this one methyl group at the here. I hope you got these three structures now. And after this, is there any other possibilities? Yes, let us try few more. Okay, so 3 we got. Okay, I am writing like this. Okay, then next triple bond is here. Okay, after this, so I am placing ethyl. Okay, and any other way we can write. So if I place here, we already got this. If I place here, we already got this. So is there any other possible way to write this? We need to write one more structure, at least one will be possible. Okay, 4 carbons. Okay, now see here. So on 4 carbons I am placing triple bond here. Now I can place methyl group here. Yes, there is no other structure with 5. See, in this 6 carbons are there, in this 5 carbons, in this also 5 carbons right now, and the methyl group position is different. So 1, 2, 3 structures, and after 5 I can trim, I can cut one more in the parent chain, I can make it 4-membered chain. After that I can place 2 methyl groups as these positions, right? So this is another possible. So there is no other possibility to write the structures with the 3-member as we tried here. So that is not getting possible, right? So up to 4-membered chain only it is possible, and these are the structures we are getting. So from that, so 1, 2, 3, 4. So 4 is our final answer. That's it. Okay. I hope it is clear now. A metal crystallizes into 2 cubic phases, FCC and BCC, with edge length 3.5 angstroms and 3 angstrom respectively. The ratio of densities of FCC and BCC. Oh, okay, it is simple again. So what is the density formula? So density I am writing, density for FCC, let us say, here I am writing. So general density formula is what? Zm by A cube into Na. So where Z indicates number of atoms here, and in the number of atoms in that FCC lattice. So M represents what? The mass, and A cube is volume, and Na represents Avogadro number here, right? So now this is for FCC if I say. So total number of particles, how many, like atoms, how many it will be? So it will be 4, right? For FCC into M I am writing, A cube as it is I am writing, Na also as it is I am writing. Okay. Similarly for rho indicates what? Density. For BCC lattice if we want to talk. So I am writing it as, what is the Z value for that? It will be 2 for BCC, M A cube by Na. Okay. Now take the ratio of these two. Take the ratio of these two values. So M getting cancelled, Na A cube. Here A cube values are varying here. See, in the A cube value for FCC it is 3.5. So I can write 4 by 3.5 cube. Okay. So here I can write 2 by 3 cube. So now take the ratio of these two things. So here 2 ja. So finally what we have? So we have 2 by 3.5 cube, okay, into 3 cube. Okay. So by simplifying this you will be getting the value as 1.26. Okay, that's it. Hope it is clear how I have taken the formulas, right? This is on Henry's law question. So what they are given? They are given 4 different gases. Their Henry's constant values are given, and they are asking us the correct order of their relative solubility in the water. Okay. So more KH, low solubility. What I am saying? More so KH, low solubility. Inversely proportional. KH is inverse, like solubility of a gas. Solubility of a gas is inversely proportional to KH. Okay. So which one is having more KH? More KH is for this. So this is the least soluble. So argon is least soluble. After this, now identify. After this, which is having like least KH, this is having least KH. So this is more soluble. So formaldehyde will be highest. Okay. Do we have any options like this? So most is, which is highly soluble, formaldehyde. Yes, formaldehyde. So argon is least, that's it. So this is our final answer. Hope it is clear how we are solving the question. Okay, see this one, the Gibbs free energy change for the reaction corresponding to the following cell. Okay, so in kilojoules they are asking. Again this is simple now. So what is the Gibbs free energy formula we have? See, this is second question on Gibbs free energy. Okay, there are 3-4 formulas on Gibbs free energy, so that you should learn those formulas. At least one question you can see in the exam. Okay, this is second question in the same paper on this Gibbs free energy. So what is the formula? Delta G equals to NF E cell we can say. Okay, so the Gibbs free energy change in kilojoules corresponding to the following cell. Okay, so like this we can say. So now N represent number of electrons changed, gained or lost here I can say for this particular process. F means Faradays. Okay, did they given Faraday? Yes, Faraday value also mentioned. For what is this E naught cell value? Okay, so how do we do this? So first of all look into this reaction. So write the reaction first. Cr, see here Cr is there with a slash Cr plus 3. It means Cr is getting oxidized to Cr plus 3. Okay, now here we have a salt bridge. So plus I am writing, and here in another compartment we have Fe plus 2. So this is converting into what? Fe. Okay, so for this process, see during this oxidation 3 electrons are lost. During this reduction only 2 electrons are lost. In a given redox reaction, always remember number of electrons lost and gained should be equal. So in order to make them equal, so I am multiplying this oxidized equation with 2, therefore it will become 2 Cr gives 2 Cr plus 3, which is 3 into 2, that is 6. Similarly Fe plus 2 converting into Fe, so only 2 electrons are changed, so I should need to multiply with 3, therefore it becomes 2 3 ja 6. Okay, it is 6. Hope it is clear up to here. So now number of electrons gained or lost is how many? 6. Okay, here value of N is 6. Okay, so F value is 96500. Okay, into what is the E cell value here? E cell or E naught cell here we can say. Okay, so how can we get this E naught cell value from these? So which is undergoing oxidation? So E naught cell I am taking E naught oxidation plus E naught, see this is oxidation potential and this is the reduction potential. Okay, direct formula I am using, not the bookish formulas. Okay, so what is the oxidation process here? Chromium is undergoing oxidation. So for oxidation, how much they mentioned? See Cr plus 3 to Cr. So this is reduction value, standard electrode reduction value, right? So but if I want to make it chromium to chromium plus oxidation, see for reduction it is minus 0.75, for oxidation it is plus 0.75, that's it. You can take as it is like this. Now Fe undergoing reduction, now take the value, how much it is? Minus 0.45. So totally it will be 0.30 volt. Okay, so you can take here 0.30. Okay, so by simplifying this you will be getting this negative 150.9 electron volt. So this is our answer. Okay, hope it is clear how we are solving this question, right? Here for a first order decomposition reaction, okay, the rate constant is given by the equation. This is how they have given the activation energy for the reaction. So on what basis we can solve this? If you look into it properly, you will get some idea. They are asking activation energy and equilibrium, like rate constant and temperature is mentioned. So where do we really seen this kind of things? In which equation we have studied? That is Arrhenius equation. What is that? Arrhenius equation, which is given as K equals to A e to the power minus Ea by RT, right? So here Ea represents activation energy, T represents temperature, this is Arrhenius constant, this is rate constant, right? So applying log on both sides, or see, just make send this A here, K by A becomes e to the power minus Ea by RT. Okay, so now send this E to this side, what happens then? So we have ln K by A equals to minus Ea by RT, that's what we get. Okay, so now ln I can write log because they mentioned it in terms of log. So in order to make that, we have log k, like this we can write. So whenever you are writing ln to log, so you should multiply with the 2.303. Okay, so that we can write here EA by RT. So what they are asking, just log k relation they given now. So log A by B, I can write it as log A minus log B. So that log k becomes minus EA by R into 2.303 into 1 by T. Okay. So this is minus log A, I am sending that side, it becomes log plus log A. Okay, like this. Now compare these two relations, two equations. See here, log A value is this much, so keep it aside because they are asking only about activation energy. Now this part is similar to this part. So 1 by T. Now here you can see minus EA by 2.303 R, which is equals to 10 power 4. That's it. Okay. So from this, what they are asking us? They are asking us to find activation energy. So from this, see minus, here also minus is there, that remained cancelled. So we have EA equals to 2.303 into R means 8.3 I can say into kilojoules they mentioned now, answer should be in kilojoules. So I can take 10 power minus 3 into 10 power 4 I have. Okay, so this and this cancel and we are remaining with 10 and 2.3, 8.3 will becomes almost 19.11. So this is 91.1. Okay, so this is our final answer. So let's look into the options. So this is our EA, activation energy, which is 191.1 around. Okay, so here we have 191.1. So fourth option is our answer, correct answer. I hope it is clear now how we are solving the question. So like by looking at the question, getting the proper idea how to tackle the question is one of the important thing that that every student should learn and that every student should habituate. So that is how you can able to understand the concept, applications of the concept. So the source of an enzyme is malt, okay, and that enzyme converts X into Y. What are X and Y's here? Okay, so here malt, source of an enzyme is malt. So that is diastase that converts starch into maltose. Okay, so first option is correct for this from biomolecules chapter. Next, in the extraction of iron using blast furnace, to remove the impurity X, the chemical Y is added to the ore. What are X and Y? So what are the impurity present? That is silica is present. Okay, in the iron extraction in the blast furnace, we have silica as the impurity. In order to remove that, we will be adding calcium carbonate. Therefore, it will be forming calcium silicate. So which will be nothing but slag. So that will be floats on the molten form of iron. So that will be removed out. Okay. So silica is the impurity. CaCO3 is added to remove this impurity. As a result, they are forming slag which floats on the molten iron that can be removed out. Okay. So option 3 is correct. Next, thionyl chloride on reaction with white phosphorus gives a compound of phosphorus. Okay, let me write thionyl chloride SOCl2 reaction with P4. Okay, so we will be getting a phosphorus compound of phosphorus, that is nothing but PCl3 we will be getting. Okay, which on hydrolysis gives a oxo acid. See, just remove this 3 chlorines, replace with 3 OH minus. POH 3 times because 3 chlorines are removed now. So this I can rearrange the formula as H3PO3. So this is orthophosphoric acid, which is oxo acid of phosphorus. So this is our O. Now this orthophosphoric acid is a dibasic acid. It can release 2 H plus ions. So that I can say dibasic acid. Okay, that is dibasic acid. Okay, and the shape of C. So here the compound C here formula, yeah, PCl5 shape is what? Having sp3 hybridization and pyramidal shape. Okay, correct only. So O is monobasic acid, wrong. Okay, C on reaction with acetic acid gives O. So this is C now, yes. So this is also nice question here, nice conceptual question it is. So acetic acid see this OH minus will be exchanged by this Cl, this PCl3, this 3Cl minus Cl minus you remove, replace with OH. There also will be getting H3PO3, and what is the other product? CH3COCl. So like this 3 moles will be formed. So our orthophosphoric acid O here formed, here also formed. So this is also correct. So 1, 2, 4 are the correct statements in the given options. Okay. So let us check once. 1, 2, 4 are the perfect answers for this question. Okay. Option 4 is correct. Which of the following statement is not correct? Chlorine oxidizes iodine to periodic acid. Actually yes, chlorine can oxidize iodine like I2. So if I say chlorine, okay, chlorine, so let us say I minus I have, so that converts into, actually this will be converts into iodate minus like this, okay, but not periodic acid. So this is HiO4, so it will not goes up to here, it will be going up to here only, okay. So in water now, in water, that is what, in water, okay. So up to here it will be oxidizes, but not here, okay. This one is what there are, which of the following is not correct, okay. So not correct, yes, this is not correct only, because what I told you, periodic acid formula is HiO4 actually, okay. So this is not HiO4, actually it is forming only HiO3, up to here only it will oxidizes, okay. So this is incorrect one, you can choose that as answer. So chlorine oxidizes ferrous sulfate to ferric, yes, this is correct only, okay. The other options also correct. So chlorine, again decons process we have discussed now. So decons process is for what? Manufacturing of chlorine. So just tell me in the comment box, contact process is for preparation of what compound, and decons process, and also Ostwald's process. So what are the process? This process is used for what? Ostwald process for production of what? Decons process for manufacturing of what? And contact process for manufacturing of what? And also soda solvay process for manufacturing of what? So all these things, if you know, write in the comment box. If you don't know, just get the answer from Google and make it clear and tell me in the comment box. I will be waiting for your answer, okay. Then next, so that we can revise them by having some random questions, okay. Phosphorus can form both phosphorus and phosphorus 5 chlorides, but nitrogen cannot. Yes, that is true, because nitrogen having only 4 valency orbitals, therefore it can form only 4 bonds, not the 5 bonds. But in case of phosphorus we have even empty d orbital also we have now. So that means it can use empty d orbitals, vacant d orbitals, so that it can expand its octet to 5 also. I mean it this valency to 5, but it is not possible in the case of nitrogen, okay. So I can say first statement is correct, assertion is correct. Reason we'll see. Electronegativity of nitrogen is more than that of phosphorus. See, electronegativity of nitrogen is more, we know that, than the phosphorus. It is correct statement, but not exact reason for this assertion. So assertion, reason both are correct, but reason is not the correct explanation of assertion, okay. Both A and R are correct. R is not correct explanation of A, right. So very important model question, assertion, reason questions. So you cannot see, not in JEE mains only, they are asking in this EAPCET also. So you should be solve more number of questions on this like statements based question, 192 statements, assertion, reason, question, statement, like this. Even if it is NEET also, there are more number of questions on this like statement 1 and 2 based, assertion, reason based questions, okay. So which one is having highest? So that is for manganese only now. So that is just from D block elements, you can check the table, there you can able to get this answer, okay. So which of the following has arrange the following in the increasing order of their spin only magnetic moment. So what is the formula we have for spin only magnetic? Mu equals to root over n into n plus 2 Bohr magneton. This is the formula, okay. So more the number of unpaired electrons, more is its magnetic moment value. So here in FeSN6 complex, So here we have Fe plus 2 with D6 electronic configuration, D6 S0 4 0. So here all the electrons will lies in the T2G set, that is like this. So no unpaired electrons. So I can say this is diamagnetic. Okay. So magnetic moment value for first one is 0. For one is 0. That will be least, I think so. Now for Mn here the oxidation state you can find. So here the oxidation state is Mn plus 2. So which is having 3d5 4s0 4s0. So which means 5 unpaired electrons are there. So 5 n value is what? 5 here. So 5 means, so it will be having 5 into 5 plus 2 7. So this is root 35. Okay. So this is the magnetic moment value, just keep it aside. So for this Mn plus 2 again, here also it is having d5 electronic configuration. Again cyanide is strong field again, therefore pairing of electrons take place in the lower energy state. So like this. So this is the electronic configuration. How many unpaired electrons we have here? So 1 unpaired electrons. Okay. So this is lesser than this. Okay. So which is maximum? 2 is maximum. And the next chromium, here we have 6 ammonia ligands. So it is also strong field, ammonia ligands are strong for this chromium. Therefore it is also inner orbital complex where the electronic configuration is like this, chromium plus 3. So D4 electronic configuration, right? D4 or D3. So D3 electronic configuration, it means 3 unpaired electrons, 1 2 3. Okay. 2 empty orbital. So 3 unpaired electrons means n value 3. So more the n value for 2. So more it is magnetic nature. So 2 is max. Then next 4, and then next what we have? So for 1 it is 0, and for 3 it is 1 unpaired electron. So that I am writing here. So least one is 1. So 2 4 3 1, 2 4 3 1. Where do we have? Let us check the options. 2 4 2 4 3 1 is our answer. Option 4 is the correct. Neoprene is a polymer of a monomer, that is nothing but chloroprene. So neoprene, chloroprene, you can remember. So chloroprene is nothing but this one. So write the butadiene, 1, 3 butadiene. This is butadiene. So place one chlorine here, that will be chloroprene unit. Okay. So 1, 3 butadiene with chlorine at the second position. So you can write, so 2 chloro, 1, 3 butadiene. Okay. So this is the monomer of this neoprene. Neoprene is a polymer of a monomer, that is chloroprene is a monomer, neoprene is a polymer. So this neoprene is formed by from this chloroprene units. Okay. Okay. So on prolonged heating of glucose with HI, so glucose C6H12O6 na, so this glucose upon heating with HI, okay, so this will forms hexane because C6 na 6 carbon, so 6 carbon 6 membered chain will be obtained, 1 2 3 4 5 6. So this is hexane. So what is our compound C? So compound C is hexane. So this which can also be obtained from Wood's reaction using sodium metal from the compound D. So identify compound D. So which metal will give this? Which of these compounds will give hexane? See, Wood's reaction is simple na. So just remove that alkyl halide part, you remove this halide part, you remove, just merge the 2 units of that unit itself. So here 3 carbons are there, so make the 2 units of it. See 1 2 3 4 5 6, 3 means 3 plus 3 6 carbon chain. So we got here hexane. So first option is correct. If we take second option, these are the 2 units, so add them, this is the 1. So this is nothing but 2, 3 dimethyl butane, but they are saying hexane na, so hexane we got in the first option itself, so 1 is correct. Next, match the following with 1 and 2. So sodium benzoate, which is used in the food preservatives. What? In the food preservatives. So I can see C4. Next, saccharin, which is artificial sweetener, B1. Okay. Next, this A is 3, A3, and D is a anti-fertility drug. Okay. So D2, that's it. Okay. So we need to check the options which is having A3, yeah, first option is having A3, B1, C4D2, that's it. So our option number 1 itself is correct. So this is from chemistry in everyday life question now. So just from textbook itself we got the question. Okay, here again what is the product Z in the following reaction. Okay, so never learn organic just for namesake, I mean just a single base, just try to learn the like application part of organic chemistry. Okay, so do not by heart the things. So if you by heart the things, you may stuck during this kind of conversion questions. So we have seen 2 conversions now in this single paper itself. So it means you should learn the applications in 2 place, and these are very basic applications, right? Cl2. So just remove this Cl and replace that with chlorine. So this is what? Sand-Meyer reaction now. So we are treating this with CH3Cl and sodium diether. So this is Woods-Fittig reaction. Therefore we will be getting, see, before exam itself I have made a video, special video on Woods-Fittig reaction for many times. I mean whatever the important questions I have discussed. So most of the cases I have discussed about Woods reaction as well as Fittig reaction and Woods-Fittig reaction. These are one of the favorite topic for EAPCET examiner. Okay, so we got Y here. For this we need to do Cl2 Fe in the dark condition. So Cl2 Fe in the dark condition means electrophilic aromatic substitution. So this is electron releasing group. So it will direct the incoming nucleophile to the para position. Therefore we got answer as CH3Cl, para position Cl to this toluene. Okay, so let us see the option. Yes, so do we have, yes, so at para position Cl to this toluene, that's it. So our option 2 is correct answer for this. Last, so aldol condensation, what is A and B in this question? Again important. See, I will tell you one trick here. So aldol means what? So this is the aldehyde group now, and this carbon is called alpha, this is called beta. So beta hydroxycarbonyl compounds are called aldols. Okay, so now how can we identify this A and B from this? So just break the bond here. Okay, now write the this side part CH3, done up to here. So now what is the other part? CH3, CH2, CHOH, like this we have now. So what we will be learning in the aldol condensation, basic definition you must revise it. So when 2 moles of carbonyl, like alpha hydrogen containing carbonyl compound, upon treating with the base forms beta hydroxycarbonyl compounds, right? So now this is the beta hydroxycarbonyl compound. So just break this bond, this is the one part. Now the carbon valence is not satisfied here. So just place this 2, and here whatever the OH group is there na, on that carbon you write it as CO, that's it. Because this carbon valence is not satisfied, that's why I am making it as CO, that's it. These are the 2 units, this is 1 unit, this is the second unit, both are same only now. So what is that? So CH3, 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 CH2, CHO, and this is also CH3, CH2, CHO. So we got option 3. Hope it is clear how we are breaking and making the starting materials. Okay, so very important approach it is. Which of the following intramolecular hydrogen, which of the following intramolecular hydrogen bonding is present? Very easy question. So catechol, if you draw the structure, it will be having OH, 1, 2 diol, it is like this. Okay, so between this oxygen and this hydrogen we will be having intramolecular hydrogen bond. When it comes to quinol, like this we have. Okay, so these are very far from each other, which are 180 degrees to each other, no hydrogen bonding. So there is no intramolecular hydrogen bonding, but intermolecular, between this molecule and the other molecule hydrogen bonding is present, which is called as inter, but not the intra. Okay, so they are asking about intra, which is possible only in the catechol. I hope how this option 1 is the correct one. I have explained properly only. I hope it is clear. Now orthocresol means in that also it won't exist now. So only catechol is perfect answer for that. Okay. So now what is the product C and D here? See, add this methyl group here so that it will become OH. See, this is the negative part, add here, becomes CH3OH. Okay, so to this add A, this is our A, to this I am adding orthophosphoric acid, it means remove this water and we will be getting, we have like this, so that we will be getting a alkene here. So this alkene upon ozonolysis, ozonolysis means what? So this is our B now, ozonolysis means what? So just whenever you have double bond, break it, okay, and make the carbonyl group, just convert these two carbons as a carbonyl group, CH3H. This side, this is the product form, and the other side we will be getting this, we will be getting this, one is C, another one is D. So one is acetic acid, one is acetaldehyde, or we can say 1,2. So ethanol, I can say this is propanol. So this is ethanol, aldehyde, another one is propanone or acetone. So option 3 is correct for this question. Hope it is clear how I am solving this kind of questions. So just whenever you have alkene, wherever the double bond is present, just make the two pieces of it, just cut them, divide the two alkene carbons and place their oxygen, that's it. You will get the respective carbonyl compounds. Next, last one, last two questions I think so. Identify the incorrect match with respect to distinguishing of this reagent. Okay, so methanol plus S, can we distinguish them? Incorrect one, na? So can we able to distinguish? Yes. So because this is iodoform test, iodoform test will oxidize this compound into acetaldehyde. So we know methyl group containing carbonyl compounds, aldehydes, ketones will give iodoform test. So this and this can be distinguished by this reagent. Methanol, they will be forming formaldehyde upon oxidation and it will be forming acetaldehyde. So acetaldehyde will give iodoform test, whereas formaldehyde won't give. So this can be separated. Okay, that's why this is not the incorrect, this is the correct one. But in the question they are asking about incorrect one. Okay, so anhydrous ZnCl2 Lucas reagent. Okay, so can we able to distinguish them? Okay, because this will be readily react, this won't react readily. Okay, somehow we can distinguish them. Okay, so then next sodium. So this sodium metal will only react with the terminal alkynes, because this hydrogen is acidic, therefore it will be react only with the acidic proton. So this one won't react. So this is also able to distinguish them. Okay, so now when it comes to 2,4-DNP test, okay, so this is phenyl hydrazine 2,4-dinitrophenyl hydrazine. So both aldehydes, ketone can reduce, can react with this 2,4-DNP reagent. Therefore we cannot distinguish them because both of them are reactive now. So this is not the perfect one to distinguish both of these things, because both will react and both will form the product. So this is a perfect one. So this is incorrect one. So it means we cannot able to distinguish now, that is what they are asking. Incorrect match with respect to compounds to be distinguished. These two compounds cannot be distinguished by this because both will react and form some product. So we cannot differentiate them. Whereas in other options only one can be reacting, other cannot be in the previous options. But here both are reacting. So this was the incorrect one. Fourth one is the incorrect one. Hope it is clear. Now last question here we have the reagent which is used to distinguish primary, secondary, tertiary amines from the mixture. So which is the reagent? So Hinsberg test. So Hinsberg test is what? Benzene sulfonyl chloride is used. Benzene sulfonyl chloride is used. So this okay. So this is SO2. Okay. So this is the benzene sulfonyl chloride. So which is used for the distinguishing or to identify which one is primary, secondary, tertiary. So we will be using this the compound which we are calling it as Hinsberg reagent. Okay. So primary amines will react with this and as well as secondary also. See, Hinsberg reagent is a proper one, whereas Luker reagent cannot separate or distinguish this primary, secondary, tertiary amines. Even toluenes and phenylings also won't work. Only Hinsberg is the perfect answer for this question. Okay. So now in the yesterday's class we have seen one question. So I just want to discuss the same question here also. Just give me some time. So is there anyone in online? Okay. Okay, Kodam Naveen. Okay. So now I have one more thing to be discussed here. Let me check the question is there or not. I will be showing you the yesterday's question. Yes. So look into this question, the half-life of a zero order reaction. See, in the last class, we have taken that as a first order, so that we are unable to solve that question exactly, because we got the answer as 2 for the first order, but they are asking for zero order. So what is the answer here? How can we do? So what is the reaction condition they have mentioned? Initial concentration of A is given this much. For the zero order, how can I write the rate? For zero order, rate equals to K into concentration of A naught, A to the power 0. So but here we know something power 0 will become 1, so rate and rate constant are equal here, right? This is the one thing you can remember. Now rate, how can I write? Dx by dt equals to K I can write, no? Okay. So by integrating these, so we can get K equals to x by t we can get. Okay, by integrating this equation. So this is the one thing you can get. So x is what? The concentration of the reactant at a time t. Okay, at a time t. So what they are asking? So for half life is given this much. So for t half, so t half is given this much. So they are asking about the time required for conversion from here to here. They are asking. Okay. So for that, in order to use this formula, we need to know the value of K. So the value of K can be obtained from the first data, initial, the primary first data what they have mentioned from that. So I can say T half of a reaction can be written as initial concentration. See, 50% completion of reaction means the initial concentration becomes what? A by 2. If A is the initial concentration, it becomes A by 2. For example, A is equals to 100. So what is the half of that? 100 by 2, that is 50. That's why I am making A by 2. Okay. So what is the initial concentration they mentioned? It is 4. So I am writing A by 2 by K. So first zero order K naught. Okay. So what is the value of A here? They mentioned 4. So 4 by 2 K naught I am writing. Okay. So from this 4 by 2 K naught, 4 by 2 K naught I have written. So from this I want to find K naught. Okay, how can I find this? So 4 by 2, see K naught I am sending this side and T half this side. So it becomes T half is how much? 0.5. So I can write this as 1 by 2. So these two cancel. We got K naught value as 4, right? So this is the one thing we need to find first. So we got constant K value, K naught value we got here. So what they are asking now, in order to find T. So T is equals to x by K naught. So what is our x at concentration at a time after in hours they are asking. So the time required for conversion of 2 to 1, that means x1 is 1. Okay. So x value is 1. So what is the K naught value? That is 4. So T, how much time it is required? 1 by 4 hours. Okay. So here we have 1 by 4 hours. Okay. I hope it is clear how simple the question is, but if we are not giving the proper approach, or if we are not reading the question properly, by simple small mistakes we can we are losing the marks, right? So we should not give a chance to lose a mark. Always try to be alert and focus during the solving of questions. Okay, I hope the session is really went well and there is no doubts. If you are having any doubts, you can write in the comment box. I will be discussing them in the upcoming sessions. So thank you for watching. Happy learning.